Hey everyone, today we're going to dig into a term you've probably heard thrown around a lot: serverless computing. Now, it sounds a little bit like magic, doesn't it? But it's not about getting rid of servers. Nope, it's about a totally different way of using them, especially on platforms like Google Cloud. And believe me, it is an absolute game changer for developers. I mean, just think about that for a second. What if you didn't have to set up servers or patch operating systems or stay up all night worrying if you have enough power for a big traffic spike? What if you could just write your code and it would simply run whenever it was needed? Well, that's the dream, and it's the core promise we're going to explore today. Okay, so first things first, let's clear up the biggest myth right off the bat. The name serverless is, well, it's a bit of a fib. Of course, there are still physical servers whirring away in a data center somewhere. The crucial difference, the part that matters to you, is that you don't see them, you don't touch them, you don't manage them, and you definitely don't pay for them when they're just sitting around doing nothing. The cloud provider, like Google, handles all of that messy stuff for you. So if the servers haven't actually vanished into thin air, what's really going on here? Let's dive into what it actually means to hand over the keys to the server room. Here's the official definition, but forget the textbook language for a second. The two most important words on this slide are dynamically manages. See, instead of you renting a server for a month or a year, the cloud provider instantly spins up just the right amount of resources to run your code for one specific task, and then, poof, spins them right back down the microsecond it's done. I love this analogy. Think about it like this. Traditional servers are like owning a car. You're paying for the car itself, the insurance, the gas, the maintenance, 24/7, even when it's just parked in your garage 90% of the time. Serverless, on the other hand, is like hailing a taxi or calling an Uber. You only pay for the exact trip you need, right when you need it. The driver, in our case the cloud provider, handles all the maintenance, the oil changes, the flat tires. It's a massive shift from ownership to on-demand access. So how exactly does Google Cloud give you this taxi service for your code? Well, it really boils down to two key players that you're going to want to know. On one hand, you've got Cloud Functions. Think of these as your specialists, like a scalpel. They are absolutely perfect for small, focused jobs that just react to something happening, an event. Like, hey, a new photo was just uploaded, go make a thumbnail of it. Bam, done. Then you have Cloud Run. This is more like your multi-tool. It's for running your entire application or your whole API inside what's called a container. It just sits there, waiting for a web request, and then spins up your whole service to handle it. All right, enough theory, right? Let's see how these two tools, Cloud Run and Cloud Functions, actually work together in a real-world scenario. Let's follow a single request from start to finish. Okay, so picture this. A user hits your API. Cloud Run, which has been totally asleep, wakes up in milliseconds to serve that request. Let's say your API's job is to generate a report and save it. So it drops that finished file into a Google Cloud Storage bucket. Now, the moment that file lands, it sends out a little signal, an event. And that event instantly triggers our specialist, the Cloud Function, which wakes up, grabs that new file, and maybe processes it or sends an email to a user. Did you notice what happened? Nothing was running until it was absolutely needed. It's like a perfectly choreographed chain reaction. Now that sounds pretty incredible, but you know how it is in the world of tech. There's no such thing as a magic bullet. For all its power, serverless comes with its own set of trade-offs. So let's get real and look at both the good and the bad. Before we jump into the pros, I want you to just look at this number for a second. 100 milliseconds. This isn't just about speed. It's about cost. In the serverless world, you're not billed by the hour or even by the minute. You are billed for tiny, tiny fractions of a second. This is the heart of that whole pay-per-use promise. You truly only pay for the exact compute time you use, right down to the millisecond. And the benefits of that model are huge. If 1,000 users or 1,000,000 users hit your app at once, Google scales it up for you instantly, automatically. If no one uses it all night, you pay literally zero. This isn't just convenient, it totally changes the economics of building something new. It lowers the risk, it lets you experiment, and it frees up developers to just focus on building cool stuff, which means you get to market way, way faster. But of course, it's not all sunshine and rainbows. There are real downsides to consider. Because your code isn't always running, sometimes it needs a moment to wake up. And things that need to crunch numbers for hours on end, well, they're not a great fit. Also, because so much of the infrastructure is hidden from you, figuring out what went wrong can sometimes be a lot trickier than just logging into a server. So what exactly is this cold start problem we keep mentioning? Well, it's that tiny little delay, that fraction of a second, when your function has to wake up for the very first time after it's been inactive for a while. Think of it like a car engine on a freezing cold morning. It just needs a second to get going. Now, for most apps, you'll never even notice it. But if you're building something where every single millisecond counts, it's definitely something you have to plan for. All right, so now that we know the good, the bad, and the cold starts, where does serverless actually shine? Let's look at the common places where this technology is making a huge impact. This is really where the rubber meets the road. Serverless is amazing for web APIs that have spiky, unpredictable traffic. It's a natural fit for data processing, jobs that just need to run whenever new data shows up. And it's perfect for things like IoT devices sending back sensor data, or for the back end of a chatbot where you have these short, sporadic bursts of activity. And honestly, this quote just nails it. The whole point of this entire shift in technology is abstraction. It's about taking away all that boring, heavy lifting of managing infrastructure so that smart people can focus on creating features and solving problems that actually matter to their users and to the business. And that brings us to a final, pretty big thought. As the infrastructure that we spent decades managing just fades into the background, what does that mean for the future of development? It's a shift, really. A shift from being a mechanic who keeps the machine running to being the architect who designs the entire experience. The focus moves completely to business logic and user value. And that's not just a technical change. It's a whole new way of thinking about how we build the future.